Okay, well, I'm guessing that some others will be coming. Welcome everyone to this week's tutorial on the Fields Academy course, CMPT 498 and 98. This week we've been discussing a lot of the fundamentals, building blocks, and elements of agent-based modeling. And today I thought we would explore some model building in our example model platform, AnyLogic, exploring some of the concepts discussed in lecture. Notably, yesterday's lecture had focused on static heterogeneity, and today we're going to be exploring a model building for a model that exhibits such heterogeneity. And in the process, we're going to be learning some about use of the modeling platform and sharpening our understanding of the mechanics of agent-based models as they are manifested in one platform. So to that end, I'd like you to fire up the AnyLogic platform that I asked you as a component of this course to download. We've got a local student coming in here, so I'll just open the door here for him. Welcome, Eddie. Okay, so I've asked you to open up AnyLogic, and I'm going to be switching to screen share here. We're going to have a fairly close-packed session here to get through our objectives, so we'll have to keep the pace up here. So once you have AnyLogic up, we're going to be going and creating a new model. So I'll walk you through this process here. I'm going to call this up. This is a splash screen, which came up in this case. I'm going to minimize it. I'm going to close out models. I had some models to show during lecture there, but I'm closing them to have a blank slate. This framework in which we're going to be building is going to be making use at various parts of our modeling of several windows. Those include a projects window over here, a palettes window out of which we'll build the model. The projects will show the different model components and properties of particular components. And over here in the middle will be the canvas. So we're going to go here and create a new model, okay, through the File New menu. It can also be created up here by creating a new model. And we're going to specifically be creating a model that is called ABM, Simple Heterogeneity, Fields Academy. And I will call it V1, okay, where V is for version. Best practices for keeping versions would be to use systems such as Git, version control systems, source code control systems. Because I don't want to require that sort of learning, I'm going to be saving them with different versions. And potentially at some times I'll be sharing different versions with you. We'll have versions for different milestones we reach. And it's important to do this and to be able to roll back to previous versions if you discover an issue with your model. Again, the ideal way to do that is with something like Git or Subversion and earlier generations, but this is an adequate approach. So V1, and we're going to choose a model time unit here of years. Okay. That's important. That's going to be our time unit of the model. It's not the time step of the model. It's not like the model's going through in discrete time and small and year-long chunks. No. It's the time unit. It characterizes as it were, the yardstick or meter stick by which we judge time. What does one mean in terms of time? Well, it means 1 year. 2 means 2 years. Okay. And we're going to finish here. And it's going to create a little model over here in the projects window. Now, it may pull up the palette for you to start adding things to the model. And we're going to come to that in a minute. But first, I want to go reflect on what's in this project. What it's created is actually the top level environment. We might be forgiven for saying the top level agent, and that's an acceptable way to view it, of the model called main. But we don't yet have a population of one or more agents. We're going to be doing that right now. Okay, so we have this population. The next thing we're going to do is to add a theory of agenthood. So when we're building these models, we'll often have several different agent types. Sometimes we'll combine ourselves to a single agent type, but quite commonly we'll avail ourselves of several. Maybe it's patients and physicians. Maybe it's veterans and service dogs. Maybe it's community-based organizations for shelter, and individuals struggling with homelessness. It could be individuals in a population who are at risk of spread of infection. But we're going to have agent types, one or more. And those agent types are going to characterize the available characteristics of those agents. They're going to provide a theory of agenthood for that sort of agent. So we're going to provide a theory of a personhood here. And it's going to be a particularly austere, simple theory, and not even one that can be said to be dynamic here, because we're focusing on static parameters like we covered in class yesterday, heterogeneity and static parameters. But to add an agent type, we're going to right-click on this model here. I think it may be Command-click or Option-click on Mac, forgive me. Right-click and say New Agent Type. Okay. And we're going to add an agent type called person. Okay. This is going to be our theory of personhood. This does not represent one person. It represents a theory of agenthood, what it means to be an agent here. And each model is going to be different, right? If we have a model that's focusing on issues with homelessness and community-based service delivery, it's going to be very different than if we're focused on one involving COVID, monkeypox, or for that matter, Nipah virus. We're going to have very different needs that are going to set the model scope. So what's going to be in person is going to reflect the model needs. What our theory of personhood is going to include will reflect model needs. But generally, it's going to include some characteristics, some elements of model state, and some way of updating that model state, some behavior for that agent, some rules by which it operates. Commonly, we'll also include elements of connection between that agent and others, as we can see here. Again, this model is going to be austere. This model is going to be minimal, and it's going to focus on this aspect of heterogeneity and multi-heterogeneity. So we're going to go to palette with this person open in our canvas. This is our canvas. What it's displaying now is something to which we need to pay attention. Here we have showing main. Here we have it showing person. we want it to be on person, showing this theory of personhood. And the first thing we're going to do is give them a simple appearance, okay? To do that, we'll go down to the presentation subpalette. Make sure you're in the palette window and go down to the presentation subpalette. And I'd like you to drag in an oval and center it on these crosshairs. That's going to mean it's going to be centered visually on where the person is in space, okay? Okay, so I create a person, I did file, new agent type, create a person class, person type. I opened up the palette for it. I went here to presentation and I dragged an oval onto that palette. Okay, so we now have a singly impoverished set of characteristics for what it means to be a person. All that means is they have a representation as an oval. We're going to go create a person of such minimalist people, if we could. That population will live in Maine. It lives in the overall global environment. So double click on Maine. And we're going to create a population. Now, I want you to watch how I do this. This is rather important. To add a population, I'm going to click on the agent type for that population. So if it's a population of person, I'm going to be clicking on person. If it's a population of service dogs, I'll click on the service dog type, service dog class. Press click. Hold it down and drag it over into Maine. I'm dragging into Maine, not into person. The population of people lives in Maine. Okay. So if you drag it into person, delete it and go and drag it into Maine. And now I'm going to call it population. Now, if you're quick about it, you can do it here. Call it that year. The other place you can do it by selecting it. You could do it over here in this properties population. And I'm going to create here this population, call population, but that doesn't mean it's a population. In order for it to be a population, I have to click here and say it's a population of agents. It knows what type they are, persons, but we're going to say it's a population of agents. How many? 100. Okay, 100 agents. 100 such agents, 100 such persons are in this population. Now, again, these individuals in the population are singularly simple, right? They're all consisting just of ovals. It's not terribly interesting. We're going to be adding heterogeneity. But before we do that, we're going to run this model, simple though it is. Run early, run often. That's how you learn. It's how you discover problems. It's how you validate your understanding, etc. Often it's good to ask, what do I expect before running it, and then run and use it to cross-check your understanding. If you do that, you'll find yourself learning faster because you have some point of reference to compare and say, oh, I didn't realize that, and learn from it. Okay, so we've just run that. How did I run that? I should have shown that more closely. Well, you can run it in a couple of ways. You can right-click on this experiment, this thing called simulation, and do run. Another way you could do it is you can go with this button up here, pull down the drop-down and say run, or you could actually say model run and choose it. In any case, I'm running it, and here we have a population of 100 agents. You can see them right before you here, but you can't really see that they're distinct because they're all right on top of each other here. Let's remedy that. Let's place them distributed around the space, if we could. So in order to do that, there's many ways to do that. There's sort of a purely declarative way to do it. There's a way that's mostly declarative. I think with this audience, I'll use that more general way that is still mostly declarative. If you go click, that is, it characterizes what we want to accomplish without spending a lot on the how. If we click on the population in Maine, remember populations live in Maine, and we go here and we go down for the characteristics of the population. Characteristics of population specify the assumptions to make for the population, and that includes location. Go to initial location and press place agents at the specified point. And I'd like you to put for their X location, I draw from a uniform distribution between 0 and 500. It's a bit crude. We'll come soon enough to making it less hard-coded. Rather than putting 0, 500, we'll make it adjust to the space side. But for now, let's take one step at a time. So we're picking for each agent in the population, we can specify their characteristics here. As we add characteristics to them, we'll be able to specify it. One thing we can do from the get-go is specify for each agent in the population their location, and we could do so here. Now, it turns out we could have the location be determined in some way based on the agent's number, and this little light bulb tells us, okay, we could refer to index for the index of the agent, or even refer to its characteristics through what's called a self reference. You could refer to self.income or self.age. Characteristics we'll be adding. But here we're just going to do it like that. Put them in space. We're going to run early, run often. And here we have our agents spread out. 100 of them. If you want, you can come. So here they're spread out uniformly, drawn from a uniform distribution for X and Y. We'll come back to that, but we're setting their location. So we have 100 people, but they're all 100, other than their location, they've kind of devoid of interesting characteristics. They have an appearance, that's all. So we're going to go back to person. Make sure you're not still in Maine. Go back to person. We're going to be coming back to our theory of personhood. And we're going to start adding some characteristics to them. Okay? The first thing we're going to do is we're going to add an age to them. Okay? So here, a person, we're going to go to palette, and we're going to go to the agent palette, and we're going to add to person, make sure it's person, a parameter. And I often like to put it over here to the left, but you can put it here to show more centrally if you like. Often doing it in Maine, I put it to the left just to keep it out of the way of any visual display I have. So I'm going to say their age. And here we have to pick its type. This is going to characterize the universe of values from which it's drawn and what you can do with those values, the behavior that's possible with this, its properties. I'm going to set it to be, and you have to move this, an int. So in other words, you pick this, and I'm going to set it to be an integer. How do I do that? Well, I can use the arrow keys here, or I can go and, I'm using the arrow keys to go up within that. Drag it down and then go upwards. So this is going to be an integer. Okay. It's actually going to be a natural number. It's going to be 0, 1, 2, 3, 4, etc. And we'll say its default value, its value, if we don't specify it at all, will be will be 0. Okay. Now, that's a characteristic of each person. So we're describing the theory of personhood here. When we want to characterize a model, we're going to have populations of people. And across a given population, we may have different characteristics for people. So the characteristics, the specific assumptions to make about our parameters, about our assumptions about people's characteristics are given at the population level. Let's go see where that is. Let's go to main. Let's go to population. And you'll see here for the population, we can actually specify what rules we want to draw for this characteristic of people in the population. So what we're going to say is we're going to draw it from a distribution. Okay. Now we could add, if we had time, if we had an hour and a half, not an hour, we could add a custom distribution and draw it from a custom distribution, for example. Later labs, we may do that. Right now, I'm going to use a function called uniform underbar discrete. Okay. Now, AnyLogic does support, I'll note, autocomplete. Autocomplete is your friend. So you can do control space if you're on Windows, or unlikely event you're on Linux like me. I can't remember if it's command space or option space on a Mac, but it'll try to autocomplete, and it will let you pick one of these. So I'm picking the uniform discrete, and I'm going to do it between 0 and 85 years. I say discrete because we have an integer, right? We're determining this integer, 0, 1, 2, 3, 4, 5. So we're going to draw it from this distribution. That also happens to be why it takes an integer parameters here. If you looked at it when it tried to autocomplete it, it uniform discrete, excuse me, I'm just showing integer min and max. Yeah. Okay. Here's a button for build. Before you actually try to run it, run early, run often, yes. But before that, build early, build even more often. Building makes sure it thinks it understands what you mean, sort of in a grammatical sense. That doesn't mean your model will be correct. It doesn't mean your model will be the best model of the situation. Certainly, it doesn't even mean that it won't have bugs or anything. But at least it will make sure that there's not a silly error, that it patently doesn't make sense, or that it has no idea what you mean by some syntax, some way you phrase things. So this is the build button, and that is something you want to use extremely frequently. And when you build successfully, it will say build completed successfully. If there's a problem, like if you did something, like if you left out, you didn't know there was an underbar here, you left this out, and you tried to do build, it would be an unhappy camper. It would say, like, I don't know what you mean, but it would tell you where it doesn't know what you mean. It would point it out. So if you double click on this, it would try to guide you to where it is by double clicking it in the problems window. The problems window provides feedback that seeks to help you identify where the source of a manifest problem is in phrasing the model and the grammar of the model, as it were. Okay, the syntax by which you've tried to specify things. It's saying something like, "You've given me an ungrammatical sentence. I have no idea what you mean. Like, here's where I'm confused." And so by double clicking on these things, it will bring you to that point. It will try to. And don't get scared by the number of things. Often it's a cascading series of errors. It gets confused at first, and then it gets more and more confused, and more and more. Just click on the first one, be brought to where it is, and try to fix it. If that's not helpful, you might go to the second. But but don't get caught up in the later ones for now, because often they will disappear once you fix the first. So I put in an underbar here to fix that, and I build, and it's a happy camper. Okay, so we've just added some characteristics of a person. Let's go see the result. Here we go. I'm gonna build this simulation. And at first glance, you can't see anything particularly notable about the situation. Now, if you notice, you still have 100 people. In order to explore this more insightfully, you'll want to use this developer menu here. You press this to get this developer panel. Okay, and you see the model's running. Nothing's changing, so there's not much point to that. But you'll notice here in this area, if you go to this developer panel here and you call it down here, you can actually see each member of the population. Here's a member of age 62, one of 28, excuse me, I went backwards again. Okay, so 28, 82, 80. Oh, we're having a set of older individuals at first, 85. Okay. And you can go through 66, 32, etc. So here we can actually browse through characteristics, and you'll see this actually carries over when we give people behavior. We have them in states. They're connected to people. We can browse their characteristics here in a quite fruitful way. We can understand aspects of their behavior. We'll come back to that. Okay. So we've given people some characteristics. Now, we may wish to enliven it a little bit. For example, I'm looking at the time. It's not a crazy idea. I think we have time for a little bit of flexibility of ad-libbing here. So if we go to person, we go to the person, the theory of personhood is person, and you select the oval and you say appearance, and you go to position and size, excuse me. We're going to set the radius here to be not some fixed thing, but to depend on their age. Okay. So in order to do this, we selected oval. We go down to the position and size for that oval at each person level. So we're describing their appearance as part of their theory of personhood. Position and size, you go to the radius. And we're going to pull down this so it's a dynamic value. It's not one that's preset. It's a dynamic value. And we're going to set this to be 5 plus, or 5.0, because it's a floating point value, plus 5.0 times the logarithm of their age plus 1. Okay. And so it's 5 plus 5.0 times the log of their age plus 1. I'm doing age plus 1, of course, because if their age were 0, the logarithm of that is not defined, but the log of age plus 1 then will be log of 1, which is 0, and it'll be of size 5. The older they are, the bigger they will get, but logarithmically, right? Okay, so what do you think? Anyone want to comment? What do you think you'll expect to see? If I run this now, what would we see? How would it differ from what we saw before? Anyone? We set the radius of their oval to be based on their age in this way. What would we expect to see?
Different size of circles.
Yeah, different sizes of circles. And the big ones would be what?
Older people.
Older people. Yes. So here we go. And there we go. These small ones are the youngins, and bigger ones are the older folks. Okay. So we have different people in the population, and their appearance indicates their age, seniority. Okay. But let's go in and add some more texture to this. We're going to elaborate our theory of personhood. We're going to add in a characteristics that's categorical. And specifically, we're going to, I think I'm going to ad lib with this a bit. Be nice if we had a ternary one. So something like full-time, part-time, unemployed, or something like that, or not employed. Okay, so what I'm going to do is I'm going to add a capacity. I'm going to use a capacity here to specify nominal values. So values that might be called categorical, but a more accurate way of saying it is nominal. So we'll do new experiment, excuse me, not experiment. What am I doing? New option list. Okay. And this is going to be called employment category. Okay. And we're going to have three possible values. So there's going to be full, I'll just say employed. Yeah, full-time employed. Make sure that you don't leave spaces. It needs to be one so-called identifier, one token, one specific word. Part-time employed and not employed. Okay. I could say unemployed. That is a certain perhaps more specific meaning than I want to. This could include kids, for example. Okay. So how did I do this? I went and I added an option list, right-clicked, and I did option list, and I added employment category. Okay. And I successfully typed these. These are going to be names for different distinct values of the employment category. There's no ordering among these. It's not ordinal. These are nominal values. Okay. Okay. Next. So that was we were just defining a set of nominal possibilities for employment category. Now we're going to actually make use of that in our theory of each person. So go to person. We're going to, from the palette, add in a parameter. And this parameter will be employment status. Okay. Now, so I've added to the theory of personhood some employment status. How did I do that? I added a parameter from the agent menu here. The type of that parameter is going to be not double, not int, not bool, not string. We have to scroll down and we will see employment category, or you can use your arrow keys to go down and you'll see employment category. We're going to add that. And its default value will be, we'll say, not employed. Okay. That means if we don't specify anything for it, what will its value be? It's not its initial value. This generally, for parameters, we seek to use them for unchanging things. This is like, if we don't specify an assumption about it, what are we assuming? Okay, now, we've added to our theory of personhood that people have not just merely an age, an integer age, but an employment status given by those three employment categories. That's our theory of personhood. Where do we specify the specific characteristics to assume, the specific values to assume for those characteristics, I should say? Where do we specify that? Anyone? Anyone remember? Where do we specify their age? Anyone remember where we specified age? We specified it in the what?
This age we have max mean, right?
Yeah, where we specified it was at the, yeah, we had a max min, and it was for the population. We're specifying it for a particular population, what the distribution is, or what the to assume about their age. So what we're going to do here is go back to main and go to population. And you'll notice now, for members of this population, this collection of agents, we have to specify something about their employment status. Okay. Now, let's go see where we can do this. Well, look, we could try to flip a coin, but we can't easily draw it from a predefined distribution here. We could flip successive coins and try to express it. I think the easiest thing to do will be to use a custom distribution. So this will be in main. We're going to have a custom distribution. And this will be called employment distribution. Where did I get that custom distribution? I got it from the agent palette, custom distribution. And it's going to be defined using options, for which option list the employment category. Okay. What's the data from which that's going to define this distribution, specify this distribution? Well, I will right now indicate full-time employed. I'll set to be 60% of this. Part-time employed, I'll set to be 30%. And not employed, I'll set to be 10%. Now, there's a wrinkle in this. If we have time, we'll be dealing with it, that in fact, we're going to want to key this off. Not only, we kind of want a conditional such distribution, or to deal with the fact that, kids don't work. At least in a developed country, we expect kids to be spared from work and from employment and to be able to attend to their education. Right now, we're ignoring age. We'll be able to explore this if we have time here. We have about 20 minutes left. But for now, I'm putting this in. We'll have to consider this the distribution. If you want, this where we're going is this going to be the distribution for adults. Okay. But right now, we'll have this as the employment distribution. Under population, now, the characteristics for this model, I think we'll simply do the following, and this will be a simple way to deal with that. We'll have a more robust way. So what I'm going to do is I'm going to here say, for their employment status, if self.age is less than 18, well, let's say 16. I don't know what that age is in Canada. Then we are going to set their employment status to not employed. Sorry, there should be a question mark, not employed. Otherwise, this is just a bit of syntax. It's a conditional statement. It's called a ternary operator. If their age is less than 16, if you want, you can put in parentheses to make it clear. Is their age less than 16? If so, they're not employed. Otherwise, I'm going to draw them from the employment distribution. And I draw it from there by calling it that's why I have this begin paren, end paren, right? Call off to that. So I'm going to put this on a bigger screen if people would like. Maybe I'll call up a little text editor here and let's see if we can here something like that. So again, it's just a bit of syntax. It's a conditional expression. It's an expression, gives a value, determines a value. So it's a little formula. If that person's age, that's the self. If my age is less than 16, then I'm considered not employed. Otherwise, I draw from the employment distribution. And if I had presence of mind, I would have called it adult employment distribution. Now build the model. Okay. So now we have people whose employment status is defined. It's keyed off of their age, and their age is determined first. So we first determine their age, and then we take their employment status. It is important for those who were wondering that age goes before employment status because the latter depends on the former. Employment status depends on age. Okay, let's go here. Let's go run this, and we'll visually inspect members of the population, and we can informally check. Okay, here's person 0. Person 0, you may recall, because we're using a fixed number seed right now, is 62 years old. They're full-time employed. Okay. How about person 1? They're 83. They're full-time employed. Okay. Person 2, 81. They're not employed. 25, full-time employed. 59. Let's see if we can get to someone. There's someone. Someone of age 0. And thankfully, they're not employed. They're employed and engaging in naps and care seeking, being fed. Okay. So here we have a little model with successive characteristics in our theory of personhood, employment status, which is drawn from nominal categories, age, which is conceptually continuous, but characterized using integers. And we have a population of set people where we're recognizing the heterogeneity of the population, and we are characterizing their diversity. We're going to add one more characteristic. Any questions on what I've covered thus far before I add another characteristic to a person and sort of add some other bells and whistles here? Any questions on what I've shown? I'll look at the chat just in case there's anything there. I don't see anything. Okay, if not, let's use the remaining minutes to add some bells and whistles to this model. while still keeping it static. Okay, we're going to go to our theory of personhood. This is a theory of personhood that gives persons characteristics, and then we're adding these, where we have a heterogeneous population for those characteristics. We're going to add another characteristic. We're going to add a parameter that's going to be called income. Their income. And this is going to be not an int, not a Boolean, not a double, and not an employment category. It's going to be a double precision value. It's going to be a floating point number. Maybe it's an amount. I probably should have said, income per month or weekly income, or chosen a better name. Hope you'll forgive me if I leave that there for the moment. Okay, so people are going to have an income, which is going to be a continuous value. Okay, so let's go back to main. Good. We're going to go to the population to set the assumptions about income. Now, it would be a measure of some delight if we could have a conditional distribution of income conditional on employment status and perhaps also on age. Alas, that's not something to which we can easily which we have at our disposal. There's a couple ways we could handle this. We could have a custom distribution for part-time employed and custom distribution for full-time employed. That wouldn't be too bad. Have a draw from that custom distribution, just like we did for employment status. That wouldn't be a bad thing. We could also specify it parametrically in kind of a way similar to this. We could draw it from a log normal distribution, from a beta distribution over, probably beta would be appropriate because that would be capped. Log normal might be a good one to use. We might also want to have that be keyed off of their employment status. So there's a couple of ways we can do it. And I'm tempted, on the one hand, to show you something new, which is in the form of a function. On the other hand, to show you continuous distributions, custom distributions. So anyone want to indicate with their hands how many people would like to see a function that computes it, and it'll return drawing it from one parametric distribution versus another based on their employment status? Okay, I see a hand up. I see two hands up. Okay. How many alternatively would like to see continuous custom distributions? Okay, I see one hand up. Okay, we'll do a function. Go. And yeah, I don't think we'll have time for both. Otherwise, I'd do both. Okay, so in main, we're going to have a function that determines income. Okay. So we're gonna drag in from the agent palette a function, okay? And we're gonna say calculate income. This function, its job in life is to return a value. And what's the type of that value? What's the universe of values from which it's drawn? And its associated behavior is that of a double. It's going to be operating here based on some characteristics. So I'll say calculate income for person, and we're going to pass in an age for that person, which is going to be an integer, and we're going to pass in their employment status for that person whose income we wish to calculate. And that's going to be of type employment category. Okay. And now it's going to determine the income to use. Okay. So what are we going to do? We're going to, there's a couple ways we could do this. The more sophisticated way would be a switch statement, but I'll use the simple if, not wanting to confuse people too much. Now I'll say if their employment status is equal to, this is double equals, we're testing if it's equal to full time employed, then we will return log normal, and we have to specify the log mean, the log standard deviation, and the min. Okay, so I will say log mean 5, log standard deviation 3, and a minimum of 0, which is automatically enforced. I'm going to put a semicolon because we're actually saying, do this, return this value. Else, if employment status equals part-time, double equals part-time employed, we will return a log normal distribution with different parameters, 3, 2, and 0, and otherwise we'll return 0. Okay. For those who might have trouble seeing that, I will put it here. Okay. And I'm going to build it to make sure I haven't done anything silly, like not put a semicolon or put a semicolon instead of a comma or something silly like that. Okay. So basically I'm saying, hey, in order to do its job, this function needs an age given and an employment status. And given that information, it checks what their employment status is, and it returns a draw from a distribution based on that employment status, right? And really this should be return 0.0. I should be careful about that. And yes, there are times where you want to be pretty careful. So this should be 0.0. So this is basically a conditional distribution, conditional on their employment status. It'll be one distribution or another. Okay, so we have this way of calculating the income for the person. It needs this information to do its job. Let's go use that. So I'm going to go click up here and copy its name because I'm going to need its name. And if you want, you could right click on this and do copy, right? Now go to population. And for income, I'm going to pass it the two things it needs to do its job, self.age and self.employment status. Those have already been calculated because those are above me here. They are earlier in this list of parameters that are, or values for parameters. And I'm going to call this function that I just defined with the information it needs to do its job. I'm going to pass in their age, I'm going to pass in their employment status, and it's going to do its job and return an appropriate value, which will be used for the income. So that's the idea. Okay, time is short, so I'm going to build the model. Built it is. It's a happy camper when it builds like this. And if it's not a happy camper, again, you can follow it. If you forgot this semicolon, it would again be all over you, and you press, you click here, and it's going to bring you to that, and you can correct your ungrammatical rendition so that it is a happy camper. Okay. So having done that, let's go run this thing in our closing minutes. Here we go. Okay. So far we don't see anything interesting. That's coming in just a minute, but let's go over here. Let's go to our panel. Let's go down and look at population. And here we have a person who's, oh my goodness, 5.62. Yeah. Okay, that's interesting. A draw from a log normal distribution with a, well, yeah, okay, person of, here we have person of age 82 who is not employed, has zero income, age 34. Okay, so something is off. I would have expected a log normal distribution with log mean of 5 to be much larger than that. That is interesting that it, maybe I'll use this distribution probability explorer. I'll do a log normal. And I'm going to do mu5 sigma 3 min 0. And I will say, okay. So I may, okay. I would have expected that to be larger. In any case, we could tweak that. I'm doing this without notes, so here, and I will, yeah, in any case, we could update those distributions. Let's go though and set their visible location to be based on this. And maybe just one moment. I'm going to check my notes on this because in the past I've done a similar example. Yes. Okay. So I was just off. I'm sorry. This should have been like 11 and 4. My apologies. 11 and 4. I was misremembering it. This is like 10 and 3. Okay. Happy. Yeah. Okay. I'm sorry about that. We're getting close to time. Let's make sure this okay. There we go. This is a monthly income that might not be out of the consideration. It is a rather long upper tail. Okay, so now let's go. So we have a fair degree of variability now. Fair enough. Some are low, and you can argue about the exact distribution, but I'll do that. I'll take it as it is. And now let's go back to the population, and let's have their location be based on, be based on their income. So we're going to set their location here, X, to be based on the income, okay? So we'll set X to be self.income. Okay? So what that means is their placement, X's horizontal axis, will be based on their income. And we can expect, and I could ask you, we're in our last minute here, so I want to ask, but we have a log normal distribution for both those categories, part-time and full-time. So we have a lot of people with comparatively low incomes, and then some individuals up here with quite high incomes. And you can see it stretches off the high components of their income. And if we were to go here, we can see this heterogeneity indicated across different individuals in terms of their age, their employment status, their income. We have further put into place mechanisms to ensure that those are not independent of one another, that indeed their employment status depends on their age, their income depends on their employment status, and by the same token, that function could, if we wanted, have it use age more generally within a given employment category. Here, it just uses age to determine, if they have no income or if they have, or use the employment status and age through the employment status for that. But we could have it depend on age. Okay, that's all we have time for today. What we've seen is a little building up of a model exhibiting population heterogeneity of different sorts, of continuous sorts at an individual level, of discrete sort of nominal sorts in terms of employment status and interrelations between them. Tomorrow, we're going to be looking at heterogeneity, moreover, at multiple dimensions of people's evolution in their state. And we'll be seeing that some of the same tyranny of scaling, of adverse scaling with heterogeneity that we saw for capturing heterogeneity in aggregate models also applies in this area of state. And agent-based models will be recommended by an economy of specification here, as well as flexibility. It bears noting that one thing we did not explore here was heterogeneity in the form of relational heterogeneity. That is coming as we get into matters of networks and spatial positioning in a way that might imply connections. So put a pin on that and we'll be coming back to it. It's a pleasure to be with you, and I look forward to interacting with you more tomorrow. Thank you.